Okay, so let me recap. So we are studying shortcut methods. Shortcut method. Okay, to find PI. That we are studying for last few lectures. We studied shortcut method for e raised to x, a raised to x. Hope everyone remember the formula is a raised to minus x and constant. That was the first part, shortcut method for exponential function. Then we studied the shortcut method for trigonometric function, sin x plus b, cos x plus b. Okay. Then sin hyperbolic of x plus b. Okay. Cos hyperbolic of ax plus b. No shortcut method is there for remaining functions. No shortcut method is there for the inverse trigonometric function. Okay. Then we studied shortcut method for polynomials. Right. Fourth, we studied, in fact, we are studying right now the shortcut method for the product of two functions. So phi of d e raised to x into v. V may be any other function of x. So what the formula is? Formula is like this. Right now it is expected that 1 upon phi of d is to be operated on both the functions. Now let me write e raised to x outside. And therefore we have to replace d by d plus a. And this is to be operated on v only. Okay. So we studied few examples. Now we'll start with few more examples. So previous part v was a trigonometric function. Now consider v is polynomial. When v is polynomial, how to solve the example, that we want to understand. No doubt the procedure will be same only. For our understanding, we are taking different examples. D square minus 4d plus 3y. Question, I think you are writing it. Evaluate. D square minus 4d plus 3y equal to x cube into e raised to 2x. Okay, so no doubt our aim is to find a particular integral only. So 1 upon, I am audible to everyone now? I am audible?
Yes, sir.
Yes, sir.
So using above formula, here is the formula. We have to replace d by d plus a. What is a here? The coefficient of x, that is 2. D is to be replaced by d plus 2. So e raised to 2x should be written on this side, 1 upon, replace d by d plus 2. Everywhere we have to replace d by d plus 2. And then to be operated on v only. Here v is x cube. The function except the exponential function is the v. So e raised to 2x. Now simplify this. D square plus 4d plus 4 minus 4d minus 8 plus 3 x cube. So you might have observed that the d term will cancel, whereas remaining terms will add, and we have e raised to 2x 1 upon d square minus 1 to be operated on x cube. And hope you remember what is shortcut method for polynomials that we want to use. So e raised to 2x. Let me take minus sign common, that I am writing in numerator, and then we have 1 minus d square. After taking minus sign common, to be operated on x cube. Right up to this step. Right up to this step. And shortcut method for polynomials is known to us. We'll use that. Okay, let me go through the next page. Written?
Yes.
74. So right now we are here. Minus sign taken common. E raised to, it was 2x 1 upon 1 minus d square to be operated on x square. Okay, correct na? Please check this. Using 1 upon 1 minus t. What is formula of 1 upon 1 minus t? 1 plus t square and so on. What is t here? T is equal to t square. Okay, so minus sign as it is. 1 t square t cube and so on. And all these things are to be operated on x square only. 1 into x square d square of x square d raised to 4 of x square d raised to 6 of x square and now so on. Okay, but we
Sir,
know that
x cube by t, sir.
x cube again. Okay, x cube, x cube, x cube, x cube. Okay, so d of x cube, d square of x cube, d cube of x cube, d raised to 4 of x cube. So first derivative, second derivative, third derivative, fourth derivative, 0. So let me use this. So minus of e raised to 2x, x cube as it is, d square, here it is, that is 6x. What about d raised to 4? Here it is. D raised to 4 equal to 0. D raised to 6 equal to 0. In fact, remaining all terms they are equal to 0. That's it. Into x cube. This is the particular integral. Okay? Understood now? Okay. Next.
6x काय झालं? 6x काय झालं?
Sorry, okay. Sorry. Oh, lite. I forget that. X cube plus 6x. E raised to 2x. Should be like this. Okay. Second example. Next. Now consider another type. V is any function. It is not polynomial, maybe polynomial also. In second part, we considered V as a polynomial, previous example. Okay. Now suppose V is any function. Yes, Radha. Example is like this. Find Pi for, let me change the page. Can I change the page?
No, sir.
Okay, fast.
Yes, sir.
Okay, so example like this. D square plus 4d plus 4y equal to e raised to minus x divided by x plus 1 minute e raised to minus 2x e raised to minus 2x divided by x square. Okay, so done. Y of p equal to 1 upon d square plus 4d plus 4 operated on e raised to minus 2x divided by x square. So using, I don't think now it is required to write the formula, but let me write it. We have to replace d by d plus a will be operated on v. Here v is equal to 1 upon x square and d is to be replaced by d plus a. Simplify it. Yes, if you simplify, what is remaining? Only d square. Right, and what is 1 upon d? D is derivative. What is 1 upon d? Integration. आप क्या शपथ लेके आते हैं क्या कि बोलूंगा नहीं क्लास में?
काय झालं?
काय बोलतच नाही तुम्ही. मला कसं कळणार तुम्हाला कळते की नाही?
सर बोलतो.
तू एकटाच बोलतोस रे राजा आणि एक दोन लोक बोलतात. इंटीग्रेशन once again. अच्छा हाँ, हिंदी में कसम बोलते हैं, शायद शपथ भी बोलते हैं. e raised to minus x log x. This is the pi particular. Okay, let me solve one more example of the same type. Can I go to the next page?
Yes, sir.
Hope everyone has written this. So particular integral is यहाँ पे माइनस. Remember e raised to x, we have to write on the left side, huh? Everywhere we have to replace d by d plus 1 and to be operated on v only. Can I write this directly? After squaring, we have d square, so minus 3d square, plus 2d minus 6d, plus 1, so minus 3. Three d square minus 3d square cancel, plus 3d minus 6d plus 3d cancel. See the constants also, they will also cancel. चेक करना है आपको, हाँ. One upon d is integration. What is integration? X raised to 3 by 2 divided by 3 by 2, है ना? उसका और एक बार इंटीग्रेशन once again. X raised to 1 ऐड करना है 5 by 2. Integration once again. 1 upon d is remaining, na? That's it. Only one step is remaining. X raised to e कहाँ से आ गया? Simplified. Hope you might have understood. Last shortcut method. I'm audible. सबको समझ में आ रहा है? Are you getting it? How much is the attendance? 34 only. What about others? अरे किधर गए बाकी के लोग? ओके, फिर अभी कहाँ पे जाना है हमें? हाँ यहाँ करेक्ट. चल आगे बढ़ते हैं. Now we want to go through the last formula of shortcut method. Okay, just 1 minute. I have to change the page. It was 76, now 77. Fifth shortcut method for f of x equal to x into v, where v is any function of x, maybe trigonometric, logarithmic, maybe different from that. Okay, so formula is like this: 1 upon phi of d operated on xv equal to x as it is minus phi dash derivative of phi divided by phi of d, 1 upon phi of d operated on v. So start from this part. Operate 1 upon phi of d on v. We'll get some answer. On answer, the square bracket is to be operated. Okay, what does it mean? We'll understand. Let me start. Okay, right question. Find pi for particular integral for, right, 1 d square plus 4y equal to x sine of x. Okay, so now y of p equal to 1 upon d square plus 4 to be operated on x sine x, using 1 upon phi of d operated on xv equal to x minus phi dash of d divided by phi of d, 1 upon phi of d operated on v. Yes, what is v here? Anyone? v क्या है? कोई बता सकता है? अरे बताओ.
Sin x.
Absolutely. v is sin x. And what is phi of d? d square plus 4. Yes, और उसका डेरिवेटिव 2d.
2d.
Right. So let me substitute the values. Y of p equal to, I'm substituting values here. X minus phi dash phi of d, 1 upon phi of d to be operated on V, that is sin x. So you might have understood this part. Try to understand it. Concentrate on this part. What is shortcut method for trigonometric function? D square is to be replaced by minus a square. So what is coefficient of x in sin x? 1. 1 square minus 1. Bracket as it is. 1 upon d square equal to minus 1. Minus 1 plus 4 sin x. That is 1 upon 3 and then bracket. चलो ऑपरेट करते हैं अभी. So 1 upon 3 x sin x, isn't it? Minus 2d divided by d square plus 4 to be operated on sin x. Now, as usual, we have to replace d square by minus of a square, but that should be done in denominator only, not in numerator. Shortcut method formula is therefore if d is in denominator, isn't it? Therefore, चलो करते हैं उसको. क्या करते हैं? नेक्स्ट पेज पे जाते हैं. Have you written all these things fast? Write it.
Yes, sir.
चलो लिखो जल्दी. Let me change the page. d square plus कितना था? d square plus 4 था क्या? हाँ, d square equal to minus 1. That will become plus 3. So minus 2 by 3 and d of sin x. That's it. Are you getting it? Everyone is getting this? देखते हैं. We'll try to understand it whether you are getting it or not. इसको सॉल्व करो आप.
हॅलो सर,
हाँ.
आपण डिनॉमिनेटर आणि न्यूमिनेटरचा डी आहे तो वेगवेगळा ऑपरेट करू शकतो, म्हणजे दोघांना वेगवेगळं कन्सिडर करू शकतो.
हाँ, why not? So for example, in previous example, if you want to operate d in the numerator first, and then denominator, that is also okay, no problem. That is what you want to ask me, na?
हो सर.
Yes, you can do like that. Your order you can decide. There is no any problem. Okay, you can operate the d numerator. That is, you can differentiate first. Then sin will become cos x, and then for the cos also same formula, na? D square replaced by minus a square, right? Na? So we'll get same answer. You can cross check.
Yes sir.
Or you can try the same thing for next exam. हाँ, ये आपको solve करना है. चलो solve करो. 2 minutes are there. Fast. Chalo, fast. Solve the remaining part and tell me what the answer is.
Sir, my call. सर सर माईक ऑफ आहे का तुमचा?
Yes. Mic was not working. Correct. You got the answer? Are you getting answer in this way or your answer is different? Now we are considering three functions. Here we consider product of two functions, now three functions. Okay. So example is like this, right? D square चलो सॉल्व करते हैं. So formula number 4 and 5 we studied before time and 4 we studied few examples at the starting today. So which formula is simple? Formula number 4 is simple. So let me use that. Okay, so I am using this formula. Right, so we have to replace d by d plus a. And what is v here at this moment? This term is the v. D is to be replaced by d minus 1. Simplify. Now we have to use the formula number 5. X minus phi dash of D Yes, on the next page, we'll use this formula and then we'll get the required answer. Yes, can I change the page? Can I change the page?
Yes, sir.
Yes, sir.
Let me change the page. X phi dash cos x, na? Is it cos x? Please check that.
Yes, sir.
Okay. Now we can cancel one d from here. Okay. Whereas for this outside part, we have to replace d square by minus a square. That is minus 1. I have cancelled one d, huh? And we have 1 upon minus 1 cos x. Let me write minus sign outside. X cos x. What is 1 upon d? Integration. Integration is plus sin x or minus sin x? Correct? Understood? You can take minus sign common and you can simplify or keep as it is. Okay. Third method. So till we studied two methods to find particular integral. One was general method. Hope you remember the general method formulas. 1 upon d minus m and 1 upon d plus m formulas. Second, we studied 5 different shortcut methods. Okay. Now third is right. And at the end, we'll understand what is the relation or difference between them. Method of variation of it is used to find particular integral of second order differential equations. Okay. Now right, consider second order linear differential equation with constant coefficient as where A, B, C are constants. Constant coefficients are required, na? General solution is, yes, what is the general solution? Y of C plus Y of P. Basic things they are as it is, there is no any change in them. So general solution is y equal to y of C plus y of P. अच्छा चलो अभी क्या करते हैं, we'll try to find the complementary function. ठीक है, can I change the page now? Okay, so auxiliary equation is required. How many roots will be there? How many roots will be there? 2, 3, 5, 8. How many roots will be there? अरे बताओ. Yes.
2.
2 roots will be
roots,
there. Huh? 2 roots. Now what will be the nature of roots? Maybe real numbers and different. Maybe real numbers and same. Okay? Or maybe complex numbers. But if we write y of C from here, how many arbitrary constants will be there? Array order of differential equation is 2. 2 roots are there. So how many constants will be there now? 2 constants. याद है या नहीं? 2 रूट्स है तो 2 फंक्शन आएंगे ना, y1 and y2. And what we know about y1 and y2? y1 y2 कैसे फंक्शन रहते हैं? अच्छे फंक्शन रहते हैं. Are they good functions? Or they are bad functions? What the y1 and y2 are? अरे कोई तो बता.
functions of x.
हाँ, x के फंक्शन रहेंगे, लेकिन what is speciality of them? कुछ तो स्पेशलिटी रहेगी. यस, क्या स्पेशलिटी रहती है? हाँ, करेक्ट. अंश बताओ. चिराग, धनश्री बताओ, व्हाट इज द स्पेशलिटी ऑफ द फंक्शंस? मदिया, ऋतुजा, साहिल, सौरभ, स्वप्नील, यश. अरे कुछ तो बताओ क्या, what is the speciality of the function? Vishaka, you tell me, what is the speciality of the function? What is y1 and y2? We spent some time on understanding what the y1 and y2 are. y1 and y2 are linearly. Now you remember linearly. अरे याद है या नहीं? Linearly dependent. Yes or no?
Yes, sir.
Everyone remember this so that I can proceed. y1 and y2 are linearly. Whatever y1 and y2 we obtain, they are linearly. अभी तो याद रखो. Independent. हाँ, ठीक है. चलो और एक बार मैं उसको I'll discuss it once again at the end. Okay, let me continue. Particular integral. Right now, pi is, we defined this before also, obtained from where? CF. How? By assigning, spelling थोड़ा देखो आप सही है नहीं, assigning specific values to arbitrary constant. So let y of p equal, we want to remove the constant, so let me replace c1 by u, some function, and c2 by v. So this is particular integral. Hope you are getting it. आ रहा है सबको समझ में? Now question remains, what the u and v are? Where u equal to minus y2 u y1 है हाँ, so you have to take y2 into f of x पता है ना, the differential equation given as a d square plus b d plus cy equal to f of x, so right hand side of the differential equation divided by w is not known to us, उसको find करते हैं, कोई problem नहीं, whereas v equal to, by default minus sign is there, so by default positive sign here, y1 f of x divided by w. Okay, now question is what this w is, where w is Wronskian mathematician given by, ये जो y1 y2 है ना, those who are linearly independent, तो उनका डिटर्मिनेंट लेना है, y1 y2 y1 dash y2 dash. Can anyone tell me when the w will be 0, when this Wronskian will be 0, Wronskian 0 कब रहेगा, कुछ तो बताओ यार, कुछ पढ़ते नहीं, कुछ नहीं, टाइम पास चल रहा है, कोविड चल रहा है, aim is to pass only, not to understand anything. चलो इधर देखो, say I have a vector v1 1 2, ठीक है, ऐसे लिखता हूं मैं 1 2, and I have a vector v2 2 4, सॉरी ये लाइन नहीं होनी चाहिए, 2 4, अच्छा डिपेंडेंट या इंडिपेंडेंट, लीनियरली क्या है, if I multiply v1 by 2 I'll get v2 ना, अरे कुछ तो याद रखो, लीनियरली डिपेंडेंट है, and if I write their determinant 1 2 2 4, tell me what the value of determinant is, 0. So whenever vectors are linearly dependent, corresponding determinant will be equal to 0. You check it for the derivative also. Now in this case we cannot find derivative, whereas suppose I have a vector 1 2 and v2 is 1 3, ये line क्यों आ रही है बार-बार, हाँ, so vectors are linearly independent, है ना, so determinant will be 1 2 1 3, 3 minus 2 not equal to 0. So whenever vectors are linearly independent, determinant is not equal to 0. Vectors are linearly dependent, determinant equal to 0. But what do we know about y1 y2, they are linearly independent, by default the Wronskian will be non-zero. Getting everyone? And this is the way to find the u v y1 y2 and everything. Okay, so tomorrow we'll solve the example. Before we stop, let me make one small announcement and then we'll stop. Okay.
सर 1 मिनिट ते पेज दाखवा ना.
दाखव एक.